Okay, now we want to think a little bit more general about our trig ratios. And one thing to notice is that there is a pattern for when sines and cosines and tangents are positive. Okay? In the first quadrant, if we think about opposite sides and adjacent sides, no matter what you're doing in the first quadrant, everything's positive. So we have this little drawing here that shows you which trig ratios of the three main ones, sine, cosine, tangent, are positive. Okay, key thing, when they are positive. Okay. And so the first quadrant has all sine, cosine, and tangent positive. In the second quadrant, your adjacent side is negative. So that makes the tangent and cosine negative, therefore sine is the only one that's positive. Okay. In the third quadrant, your adjacent and your opposite are negative. So that makes sine and cosine negative, but tangent, since you have a negative over a negative, ends up being positive. And then in the third quadrant, your opposite side is negative. So that makes sine negative and tangent negative, but your cosine's positive. So we have a nice little handy acronym to help you remember which ones are positive. In the first quadrant, all of them. In the second quadrant, sine is. In the third quadrant, tangent is. And in the fourth quadrant, cosine is positive. And so we can use our All Students Take Calculus to remember which of our trig functions are positive when. Okay? Now what we're going to do is look at, if I know one of my trig ratios, how can I find the other ones? And so the given piece of information here in part A says that the cosine is negative. And so if I think about my four quadrants, where could I possibly have a cosine that is negative? Okay, well, we have all of them positive here. Sine is positive, and it's the only positive one here, so cosine could be negative there, or cosine is negative there. Tangent is the only one positive in the third quadrant, so that means cosine's negative there. And then cosine is positive in the fourth. So I'm either in the the second or third quadrant, since my cosine is negative. Now I have to be given a little extra information like this, the fact that the tangent is also negative. So if cosine's negative and tangent's negative, all students take, all right, tangent's positive here, so it can't be here, so this is no. Let's just cross it off like that. And so that puts me in the second quadrant. It's the only place where I can have a negative cosine and a negative tangent. So I know that much. I know my angle's somewhere between 90 degrees and 180. So now if we think about it, we want to draw these out. Excuse me. We want to go ahead and label our sides accordingly so we have this ratio. So let's go ahead and draw our reference triangle. And so here's our reference angle that we look at. Even though that's not technically theta, that's our reference angle. And so looking at that reference angle, if our cosine's negative 4/5, we're going left, so that's where my negative is going to go. And then it's adjacent over hypotenuse. Remember, cosine is adjacent over hypotenuse. So it's -4 for adjacent and then 5 for hypotenuse. Now that we know that, we can find that third side. Hopefully you would be thinking that that's by Pythagorean Theorem. So let's find that third side. Maybe you know. What's that one set of angles or set of side lengths that we know for a right triangle? Maybe you know 3, 4, 5, that set. And I see the 4 and the 5, so this must be 3. Okay, we could always do it by Pythagorean Theorem as well. We have an unknown side, so we have our hypotenuse squared, pi squared, equals our unknown side, maybe we'll call it A, and then our known side of -4 squared. And we solve that out. 25 equals A squared plus 16. If I subtract 16, I get 9 as A squared. And so therefore A has to be 3. And so here we find that this side is 3. Okay? And now that we know that third side, we can give all the remaining ones. And in this case, we're looking for sine and tangent. So our sine of theta is opposite over hypotenuse, 3/5. And our tangent for theta is opposite over adjacent, so -3/4. Okay, let's look at that again and throw in some of our inverse functions, or reciprocal functions. So here we have the fact that secant is 5/3. Okay, secant, which is that the reciprocal of? Okay, hopefully you know that that's the reciprocal of cosine. So cosine is positive. So let's figure out which quadrant that could be in. All are positive here, so it could be here. Students, S, sine is positive here. T, tangent. C. So here's where our cosine. So it's either the first or fourth quadrant. We're told our sine is negative, and so it can't be here because this is where all of them are positive. And so that puts us in our fourth quadrant. And then let's draw our reference triangle. Draw our perpendicular to the x-axis. And so theta is technically from the initial side all the way around to our terminal side, but the angle we're going to look at here is right here. And then with that, we can label our sides. Now it's secant. Secant is the reciprocal of cosine. And so the cosine must be 3 over 5. And so cosine is adjacent 3 over 5. There's our 3, 4, 5 triangle, so this must be negative 4. And so finding now again sine and tangent. Sine is opposite over hypotenuse, negative 4/5. And tangent is opposite over adjacent, so negative 4/3. All right, and one last one. Last problem. I know this note's been a little bit long. All right, our cotangent is undefined. How does that happen? Well, that means I must have a fraction with 0 in the denominator. And so let's remember what cotangent is. Cotangent is the reciprocal of tangent. So for cotangent, tangent's opposite over adjacent, so this is adjacent over opposite. So our opposite side must be of length 0. Okay, anytime that's the case, we must be on an axis. Okay, so normally our opposite side, if we just think, and I'm going to just, again, sketch it really lightly there. Normally our opposite side is the y value. It's the vertical piece here. And so in order for me to have an undefined, I have to have 0 for my opposite side. In other words, my y must be 0. So that puts me either here as a possibility or here. Okay, we need to decide which of those is going to be the case. Okay, well then it gives me a little extra hint. The cosine is positive. Well, cosine is adjacent. Okay, the adjacent side was this x length over hypotenuse. So in order for it to be positive, I need my x length to be positive, not negative, so I don't want that one. And so that puts me here. My angle is either 0 degrees or 360 or any multiple of that. And so to find the remaining one, so I have this point at 1, 0 that we're going to use. Now we have the fact that we need to find sine. Okay. Sine is opposite, okay, which is normally the y coordinate, so I need my y over hypotenuse, which is the r. And so the y value is 0, and 0 over anything is 0, as long as radius is not, as long as r is not 0, which it isn't. And then tangent is opposite side. Again, opposite side would be this vertical side, so that's the y height, so it's the y value, over adjacent, and the adjacent is the horizontal distance, so that's the x value. And so that's 0 over x, which is 0 as well. Okay, and we're able to find the other two values, the sine and cos or tangent that we were looking for. Okay, that's it for today.